Hey math fans, we're on section 4.2.3. Let's get started. Today we're going to learn about residuals, but before we get started on that, let's review what we've already talked about. As you can see from this example, there is a number of data values for the number of goods versus how much something costs. And it makes sense that as the number of goods increases, it's probably going to cost you more. And the question is could we come up with a way to predict, based on the number of goods, could we predict how much it would cost us in dollars? The first thing you would do is you would try and make a scatter plot. And as you can see to the left here, we have a scatter plot. Here are the 4 data points. And then the next thing we talked about is this idea of what is called the line of best fit. It is a prediction model. It is the red line that I've just drawn on the graph here. And notice that not all the dots are going through it, because your predictions will most likely not be the same as the actual values. Now, prediction models, I just want to note, are denoted by this symbol right here, the Y hat. I'll have to add it in because it's a very difficult symbol. But this Y hat means that that is a predicted Y value, and sometimes it will be above or below, or in other words, we'll be over or underestimating what actually happened in real life. So what is a residual? Well, a residual is the distance between that observed data value. And as you can see, there's a few observed data values. I'm looking at this one right here. But the residual would be the actual distance from that to the predicted data value, which is either going to be above it or below it. If it's above the regression line, this is a positive residual. If it's below the regression line, it's a negative residual. And right here is an easy formula. Residual equals Y, which is your observed Y value, minus Y hat, which is your predicted Y value. In other words, it is your actual Y value versus your predicted Y value, which again, we're going to denote using Y hat. The reason why we find the residuals is because when we make a residual plot, we can see if a linear model is a good fit. If the residual plot looks random, that means that the points are following the line. That would mean a linear model is a good fit. However, if you see in the residual plot, if you start to see a curve or some sort of weird pattern, a linear model might not be the best fit. So let's calculate some residuals. The first thing we're going to do is we're going to add a couple more columns to our XY table here. We're going to add a predicted column, and then we're also going to add the residual. So let's calculate what would the predicted cost be for if we had the number of goods being 2. Well, we already know in real life that the actual cost is 5, but according to our prediction model, what we can do to estimate is we could substitute in 2 into our Y hat equation, or our line of best fit equation. When we substitute in 2, we get a value of Y hat equals 4.81. That's our predicted cost, a little bit under the $5. So our residual is going to be 5 minus 4.81, Y minus Y hat. And we get a value of positive 0.19. Well, what does that mean? Well, it means that our actual data value of 5 is above our prediction, which down here is at 4.81, which means that the distance from here to here is positive 0.19. We actually underestimated, okay? Our actual value was $5, but we underestimated by about 0.19 or 19 cents. Repeat the same process for the number of goods being 4, 9, and 10, and you get the rest of the residuals in this data set. Now notice that the first 2 residuals are very small. In fact, when you zoom out, you can barely see that 0.19 right there. And this is, again, it was barely above the regression line there at 0.03. That even looks like it's hitting the dot right there. But as you can see, this was a pretty big negative residual right here. This is negative 0.187. And right here, fairly sizable positive residual of 0.155. Remember that a positive residual means we underestimated by a certain amount, and then a negative residual means we overestimated by a particular amount. Now let's make a residual plot. The first thing we're going to do is we're not even going to focus on the actual y value or the predicted y values anymore. In fact, a residual plot is just going to be the number of goods, your actual x value, and the residual. So you make a graph like I've shown below, including the y-axis. It's going to be centered around 0 if you have a fairly decent regression model. And then you graph each of them, the number of goods with the residual. So right here, this is 2, the 0.19. Right here is 4, 0.03. Over here is the 9, negative 1.87. And then finally, you got 10, 1.55. There does not seem to be a pattern here. In other words, there's some positive residuals, there's some negative residuals. You basically want your residual plot to be following the x-axis in a random way. And if that happens, then you would say a linear model is a good fit. Here's a couple more examples, obviously with more data points. The first one, the residual plot looks very random. So I would say a linear model is a good fit for this first one. It appears to be random. There doesn't appear to be any pattern. But in the second one, look at this. There's definitely a curve going on there. A linear model is not going to be a good fit. And that's going to do it for this section. We'll see you in class.